Okay, so let's move on to solve the challenge problem of chapter 17. So the first one, if fx equals 0 is one of them, is there any other things for f3x equals 3fx? So it's pretty linear, right? 3x is 3x, so you can see if fx equals to the ax, right? So we can see the 3 times fx equals the 3 times ax, right? Then f of the 3x equals a times the 3x also equals 3x. So any linear function can also satisfy this. How many square units are in the area of this triangle, okay, of the x and the y intercept? So you can see the x, the y of the intercept. So the value here is the x equals -2 or x equals of the 3. Then the y value will be x equals 0, right? 0 minus 3 of the square and 0 plus 2. So you can see it's 18. So here is the 18, 0, 18. So we want to see the triangle, okay? We have a triangle, then you can see the area is half of the 5 times 18 is equal to 45. Okay, then next, you can see the if f will be the function. Let's draw the picture, okay? So let's see, this is the if this is the fx, okay, then the f negative x is symmetry along the y, right? So we can symmetry along the y. So let me change another color. So this is y equal f negative x. Then what's the relationship between the f negative x to the f negative x plus 2, right? So you can see the negative plus 2 means when the negative x is equal to -1, right? And negative plus 2, when negative x is equal to -1, the negative plus 2 will be the 1. So that means at the -1, you will take the value of the 1, right? So that's here. So that means all the values has been shifted, parallel transform, shifted by translated, okay, by 2 units. So this is the f2 minus x, okay. So this one, okay, so it tells us the f is a function such that we reflect this function over y equal x and the resulting exact the same original ones. So when you reflecting is exact the same, means this one the function is a symmetry to the y equals x, okay? So this y equal x is symmetry line. So this point will getting reflected to this point, okay? So now let's see, this point is a is x1 and y1. So this is the b is also on the graph is y1 and x1. So now you have the y1 is equal to fx1, right? And you also know the x1 is equal to the fy1, right? So from here we can see if there is the inverse, x1 is equal to f inverse of the y1. So compare these two, you know f is self-inverse. So for b, you know fx is also equal to f inverse of the fx is equal to f inverse f goes gone is x. So the function of this is such that f and f inverse is the same, right? Self-inverse. So y equals mx plus b, then x equal to y minus b over m. So interchange the xy, we can see also write as the m over x minus b over m. So now we know the m equals 1 over m and the b equals the negative b over m. So now let's see the case 1 is m equals 1, then b is equal to negative b, so we have the b equals 0. The case 2 is m equals negative 1, then b equals the b, so we can pick any b. So yeah, both of them can possible. This one is how many real solutions does this one have. Okay, so let's draw some pictures. Okay, the first, let's draw the y equals 2x. Okay, so we pass in the 0 1, and you can check if we see the x equal 1 to the 1 is 1 cube plus 1, so they are equal, so also 1 is a solution, right? So 1 is also a solution, so that means it's the and the x is also a solution, right? 0, x equals 0, yeah, 0 is also a solution. That means this one is like this, okay? Because exponential always grows very fast, okay? So now in this case we can see we have 1 2 3, okay? So the real solution is 3. Next, f satisfy this, so fx equals to 8 when there is a domain for this to be satisfied. Okay, now let's draw this one over multiple of the 3 standard, multiple of the definition. Okay, so let's draw the 3. Okay, so here is the 0 and 8, so it's 0 and 3. Okay, now let's extension it. So for the 3 and 6, right? So x greater equal than 3 less than 6, right? So we need to convert it back, right? So fx, if x equals 6, right, is 2 times f of the x minus 3, right? So if x equals to the 6 is 2 times the f3, so it will be the 16, right? So the f3, if f is a 3, right? So its 3 will be 2 times the f0, right? So 2 times f0 will be 16. So now if we extending this one to the 16. Okay, now if we go to the left side, right, and go to the left side, we need to rewrite it. So x plus 3 equal to the 2 of the fx. So now the fx is equal to 1/2 of the x plus 3, right? So now we know if our domain is from the negative 3 to the 0, right? So the negative 3 plus 3 will be 0. It's half of the f0, so it becomes a 4. Right? So next one will be equal to the 2. The next one will be equal to the 1. The next one will be equal to the half. Okay, so that's why this is the picture. Okay, you need to rewrite it to propagate everything step by step. So the problem is in the problem of the we show that this one is a times of the roots of this. Okay, so this one is simple to prove. Let's see, is plus the bx plus the ac equals 0. So the delta is the b squared minus 4ac. Then the x is equal to the 2a negative b plus minus the root of the delta. And this one is the ax squared plus bx plus c, then equals 0. The delta is also the same thing, b squared minus 4ac. Then the x is equal to the 2a negative b plus minus root delta. So you can see this one is a times of this, right? So this one times 1 over a become this roots. Okay, so find a fourth way to show the roots is a times of that. Okay, let's do it. So now let's do x over a. Okay, so if x over a is equal to the a times the x over a of the square plus the b times x over a plus the c, right? It becomes the x squared over a plus the b over ax plus the c, right? So now we can see the 1 over a of the x squared plus the bx plus the ac equals to 0, right? Did you see this one? So the solution to this one times 1 over a will be the solution to the new one, right? To the ax squared plus bx plus c. This is another way to prove it. So the Kevin built a function that produced this one as long as fx is produced. So this is the Calvin, right? So if you input the x, this doesn't change the function, right? It changed the x into the 2x minus 3. Okay, then the hop, this is the hop h function, right? So it changed the x into the ax plus b, right? So whenever this one is put in, Hobbes choose the a, b so that his machine will undo Kevin's machines. Okay, so when Kevin do this, and when this passing into that, the output will be x. So let's see, the a times 2x minus 3 plus the b equals x. Okay, that means the 2ax minus the 3a plus b equals to x. Okay, so in this case, we can see the 2a equals 1, then a equals 1 half, and at the same time, the b equals the 3 over 2. Okay, so this is the answer. So that's all the challenge problems for this chapter. Thank you. Bye-bye.